Here's a brief overview of some more advanced class and object-oriented concepts. So is-a versus has-a relationships has to do with relationships between classes, different kinds of relationships. The object class is the ultimate parent, the ultimate base class from which all other classes are ultimately derived in Java. So it has some aspects we need to understand. The idea of driving classes, how do we do that? How do we override methods? And following this discussion, there's a demo and polymorphism, briefly about it, and then there's also a demo following this as well. So is-a versus has-a relationships. And is-a relationship is inheritance. And conceptually, we can see a dog is an animal. And so it kind of makes sense when we say that. And so a dog is a specialization of some kind of animal. And so is-a kind of makes sense in that context, as opposed to car is an engine or engine is a car. That doesn't really make sense. And so a different kind of relationship is has-a, kind of an aggregation or composition. And so how this would be implemented would be like car has a variable within it holds an instance of an engine, or a car has an array of four wheels, something like that. And so you can get basically one class is in one instance of a car is composed of instances of other objects. And so that's kind of the has-a or aggregation relationship. Okay, so briefly on those. The object class, a very important class in Java, the base class for all others. And in this diagram, picture extends from object. So picture is a object, although object is so general a term it doesn't necessarily make sense. But this is an inheritance relationship. And in Java, if you just say class picture, it implicitly does the extends object for us. So whether or not there's no way to create a class without it extending object. You could have other descendants of picture. You could extend picture, but picture extends object. And so there's some aspects of object that are in everything, right? Or all aspects of object are in everything. And so if we just go to the docs for the class object, we can scroll through here. Here since the beginning, superclass of all things, even arrays implement the methods of this class. So no arg constructor, and then a variety of methods, like the equals method that we've used in this, like when we were comparing, we saw comparing strings, comparing arrays, comparing integers, equals method. So let's see how the equals method is defined within the object class. And basically the summary is the most discriminating possible equivalence. Basically, it compares the reference variables. If they're the same, so it compares this versus object, since this is an instance method, this versus object, and if they're the same, then it's the same object because, well, it's pointing to the same area of memory. Otherwise, it's not. And so that's the default implementation of equals, and that's what arrays use. String and integer, like string, for example, overrides this and provides a comparison of the characters in the strings. Okay, so this is the default one that's provided if you don't override it. But if you have a class that overrides it, you can define your own behavior. And we'll show an example of that after this. So derived classes. So a couple of examples. ToString, very commonly overridden. So you can like print out your object and it'll show, the key values of key fields in the object. It's helpful for debugging. And then the equals method, how do you define whether things are actually equal? So overriding, an example of toString. So if we create our class picture here, then basically we just need to match what's in the method header that we're overriding. That's the basic idea. We match it. And so it needs to have the same name, return type, parameters or lack of parameters. So this is overriding, not overloading. Overloading, recall, same name, different parameters or different numbers or data types of parameters. But overriding is it needs to match, basically, of the superclass that it's overriding. So it's replacing the method. And this @override compiler directive tells the compiler that we're intending to override the other method, and then the compiler can verify, yes, there is another method that's being overridden. Just in case we've misspelled it or something, we're intending to overwrite it and we don't because it's a misspelling or some match. So this is just to tell the compiler to help us out, verify it is overwriting another method. An example, we have to return, and so we can just say picture, maybe pass in whatever the values of attributes of a picture are to print them out. If we want to refer to the superclass method, we can do that. And so this is just calling the superclasses. In this case, the superclass of picture is object, so it's calling object's toString method, getting the results, and then appending it to picture. So how to override a method. And then you can do whatever you want within your method. You don't have to call the superclass when you can, but you can do whatever you want within your overridden method. Equals is another method we've talked about several times, and basically how it's defined in a class. Like, how do you define whether two pictures are equal? Is it equal size, so they'll fit in the same kind of frame? Are they having the same content, essentially, like the members of a family? Or is it something else? How do you define that? And so the equals method is how you do that. So you have to match what's in object and then compare this instance with the parameter and define what it is. And after this discussion, there's a demo of actually doing that. Polymorphism, runtime polymorphism, is basically determining at runtime what method to run. And so here's a little example to illustrate this. So we've got a new instance of picture, and we know picture extends object. So actually our new instance of a picture contains all the instance variables of picture and object, and could call all the methods of each. So we're assuming in this case that picture also had a toString method. Okay, so picture and object. So we create a new picture, and now we're saving it to a variable of a class higher in the hierarchy. So this is called an implicit or an upcast. All upcasts are implicit. It's changing the class, the data type, essentially to something higher in the hierarchy. And since it's higher in the hierarchy, upclass, object is more general than picture because picture has everything in object plus some. So it's always safe to upcast. And so we've done that here. Now, the question is, so within O is a reference to a picture object. And if in this line of code we call the toString method, does it call objects toString, or does it call pictures toString? And the compiler will look at this and say, oh, you've got an object, and the class object has a toString method, so I'll allow it. But then at runtime, what happens is it will actually call the toString of picture, since this is actually an instance of picture and picture has a toString method. So that's just a brief example of runtime polymorphism. And there's another demo following this, little more advanced. So that's a brief overview of some more advanced object-oriented concepts.